Okay, so for what we have, let's say just taking a sampling of what we have for, let's say, the row echelon and the reduced row echelon forms. Okay, so you have with a 3x4 equation system. So like in the case, if you're looking at solving for x, y, and z, like the first row, you have like x plus ay plus bz, okay, is equal to alpha. And then for the second, okay, we would have like the 0, 1c. This would be like in reference to y plus cz is equal to beta. And then we have for the last row, okay, this would be like saying that z is equal to gamma. Okay, and if I were to use back substitution, okay, I could like take gamma and solve for y. Okay, and if I were to perform reduced row echelon form, okay, this is where you have only, like for the first row, you have just the coefficient, non-negligible coefficient matrix to be for what we have at x, second row only for y, last row only for z. Okay, so you have like going back, duplicating, you have like z is equal to gamma, and you have like with the second row, okay, you got like 1y, and we say that y is equal to pi itself, just using a general case. And for the top row, okay, you have only the non-negligible coefficient is 1 in the upper left hand corner, and this means reference to x, and we say that the corresponding solution, okay, we have at delta. Okay, and let's say that if you're looking at solving, okay, using matrices, and we'll say that we have as a system of equations, okay, and we'll say that we have, I'll just go with a two equation system, okay, and we'll say that we have 2x plus 3y is equal to 7. And I'll go ahead and say that we have that y is equal to 2. Okay, and for this particular case, all right, now I could go and back substitute, okay, because you have y given at 2. But now in terms of what we have, putting in terms of a matrix, okay, so you got 2 for 2x, 3 for 3y, and again we have equal to 7. And if you notice, we have y is equal to 2, so there is no x present. So you got 1y is equal to 2. And if I put this in terms of row echelon form, okay, so what I have in the upper left hand case, I want this to be 1. So we have in the process, I'm going to be taking, so if I transition from 2 to 1, in effect I would just be taking 1/2 of the first row and upon doing so, okay, so we have 1, 3/2 and 7/2. Okay, I still have 0, 1 and 2. Alright, so for what I have at this stage, okay, this part, okay, that is the row echelon form. Again, this comes from the Gaussian elimination. But again, if I go all the way and solve for both x and y, okay, y is already baked in at 2. And let's say that if I look at taking the Gaussian-Jordan elimination, okay, so got 1 and 0. And again, just kind of match here. Okay, so I have the bottom row with number 1. Okay, and I want the 3/2, okay, to be at 0. So I'm going to be looking at, in this particular case, to go from 3/2 to 0. Okay, so just looking at the correspondence, I can say that the first row minus 3/2 of the second row is going to lead to the reduced row echelon form. Okay, so you got 1 minus 3/2 of 0 is still 1. 3/2 minus 3/2 of 1, okay, that will go out. Now 3/2 of 2 is going to be 3. And for what we have in this particular case, right, so you have 7/2 minus 3/2 of 2. So it would be 7/2 minus 3, or 7/2 minus 6/2. And so we're going to have 1, 0, 1/2. And for what we have here, okay, that's going to be the reduced row echelon form. Okay, so for what we have in terms of the solutions, okay, so we have 1, 0, 1/2. Okay, so that's going to be at x is equal to 1/2. And again, we had that y is equal to 2. So just looking at, kind of going back to what we have in the original setup. Okay, so again, if I were to back substitute, okay, so you have x equal to 1/2. 2 times 1/2 is 1. 3 times 2 is 6. 1 plus 6 is 7. And again, we have that y is equal to 2. Okay, so this is going to check out.